Hi there. In a previous video we have seen how to build a basic alarm system to demonstrate some basic electronic devices, and we used a diode as an indicator and a buzzer also as an acoustic indicator. Now we are going to build a similar system, but from the digital perspective, from the digital point of view, using digital devices. In particular, we are going to use NAND gates. So there are some things that are similar, like our output indicators will be the LED and the buzzer as well. We will need an input. For our input, we'll build a circuit that will generate a signal using a photoresistor and other sensors. But all the processing or the calculations could be done from the digital point of view. So instead of playing with the properties of transistors individually, we are going to use logic gates. So basically we want an alarm system that when an input is activated, this could be a block diagram. Okay, there's some input that comes from some kind of sensor, like a light sensor. When this is at a high value in the digital world, we call it a 1. And we have a second input that is like an on-off switch. Okay, when it's 1, it means that the system is connected, but when it's 0, it is a low voltage. We don't want the system to operate. Okay, yes, a way to easily disconnect our system, and the output will be the signal that will activate our alarm. Because we want to use the same kind of circuit that we used before, which is we have a diode with its current limiting resistor. When we want to activate the alarm, this is VCC, we want this to be low in order to get current going through here. Okay, so basically this can be solved with what we call a NAND gate, because a NAND gate behaves like in this table. If inputs are X and Y, the NAND operation is as follows. When it's 0, 0, it is 1. When it's 0, 1, it is 1. When it's 1, 0, it is a 1 as well. When it's 1, 1, the output is a 0 value. Okay, this is actually the opposite of the AND operation. So in this case, the output is low only when both inputs are high, right? So now I have to build the interface to the outside world. Okay, this will be a way to sense our output, and so I need, if I want the alarm to activate when the input is 1, and then we can use a sensor that makes a 1 here. To do that, we will use the same circuit that we used before, which is basically we are going to have our power supply. This in here. We are going to have our power supply here. Then we have our photodiode that receives light. It goes to a potentiometer that will serve to adjust the sensitivity, and this will give the signal for our system here. Okay, we'll use a NAND gate here, and it will go to the output of our circuit. Okay, our limiting resistor, our diode goes here, and all that goes to the power supply. Of course, we can add a buzzer like we did before. And the other input, we just can use a switch. It is like we can use a switch to decide if we want to connect or disconnect the circuit. So it could be basically like this. Okay. Of course, this NAND gate has its logic input, logic outputs. This NAND gate also have to be polarized. We have to put energy into the NAND gate. When we design digital circuits, we don't make it explicit, the power supply connection. Okay, but in this case, it may be useful to know that we have to connect this to VCC, and we also have to connect the ground node of the gate to the ground node of our circuit. Okay. Okay, great. So now, where do I find these NAND gates? For prototypes, there are a series of discrete components, which is the 7-4 series that have many integrated circuits that have a few gates inside. We are going to use the 7400. This is a chip that has 4 NAND gates in the inside. Something like this. All this goes into a chip. It has the mark here, and it has several terminals, 1, 2, 3, 4, 5, 6, 7 terminals here, another 7 here, 5, 6, 7, and NAND gates go like that. This terminal here is intended to be connected to VCC to give power to the whole chip, and this terminal here is the ground node. Okay, and now every block of 3 inputs of 3 terminals go to the different NAND gates. So in these 3 terminals we have the inputs and output of one of the NANDs. These terminals are the inputs, and this is the output of another NAND, and so on and so forth. Okay, so it's so this is our 7400 chip. We are going to use a chip like this, right? Okay, so I'm going to make connections easier. I'm going to connect the chip here. We are going to, typically we won't connect the power supply until the end, not to ruin the chip. And as you see, the output goes directly to this node here. Okay, so we have to decide which of the NAND gates we want to use. We can use any of them, like this one, for example, the one on the top. You see the ILD is already on because that output should be low. And in order to test our chip, I'm going to connect cables to the inputs of the NAND. Okay, so we have cables connected here and here, and the output connected to the LID. And this way we can check the operation. Okay, we are going to check it. If I connect both inputs to 0, which is down here, okay, the output should be high. Okay, it's not high actually, because if the output is high, the LED should not light, but the problem is that I have not connected the power supply. Okay, so my circuit is still not working. I need to put energy inside the circuit. So I will connect the power supply, this to the positive terminal. Now my circuit is working, and you see it's as expected. Okay, the output, the LED is off, the output is low, and the output is the output is high. Okay, and because in our case it's the output is high, it will not turn on, right? So this way. Now to make the output to be low and the LED to light, I need to put both inputs in at 1, so I can check, connect one, connect the other one. Okay, and now it's working. Okay, it's in this case is when I have my circuit working as properly. As you can see, if I do not connect some of the inputs, the output is the LED is on, so the output is also 0. So not connecting an input makes the NAND gate behave as if the input is 1, but it's not recommended, because the inputs of a logic gate should always be connected to some power rail. Not connecting the input, leaving it floating, means that you don't really know how the circuit is going to behave. Depending on how it's built in the inside, it can work as a 1 or as a 0. So not connecting a cable is not an option. Okay, a 0 value is never a non-connected signal. Okay, you always have to connect it to anything. Okay, now we know it's working. We want one of the nodes to use it as a switch. Okay, I will use that node here. I don't really have a switch at hand, so I will do it manually. If I want to activate my circuit, I will connect it to the positive terminal. If I don't want it to be connected, I will connect it to the negative terminal, right? So I'll leave it connected, and the other input is the one I will connect to my sensor. So I'm going to build the sensor part again. We use the, like we did before, we have our photoresistor, our potentiometer there. The middle terminal of the potentiometer is the one that goes to the other input of the gate, and one of the sides of the potentiometer I have to connect to ground. So more or less I have a circuit that is equivalent to the one we've seen in the previous video. Okay, if you see, when there's only when there's light and my system is connected, I'll move it here just to make it more clear, and my system is connected. Okay, when there's light, it's 1. In this case, because it's a NAND, the output is 0, and it will give me a signal. So it will detect when there's light. Okay, if there's no light, it will not detect. And again, I can adjust the sensitivity with the potentiometer. I can now connect also the buzzer. You see? There's no light, there's light. There's no light, there's light. And also we have our on-off switch. If at any point I want to disable the circuit, I just the other input of the gate I connect it to 0, and then it will not work anymore. Okay, I have opened that circuit. Not there's a small mistake here, because when I open this, I want it to be 0, so I have to put some resistor here. Okay, a 1K resistor will be enough. So when I open the circuit, I'll be sure it will go to 0, right? But because I don't have a switch, I simply manually connect to VCC or ground. But I have a way to manually activate or not my alarm system. Okay? As we did before, I can make my system. Okay, it will detect light. I can make my system to do the opposite, basically by reversing this part here. I will disconnect it to avoid the sound. So I can make my system to do the opposite by reversing this side here. Okay, I will make it explicit. Basically, we can connect our potentiometer here. And we'll go to our photoresistor and the middle terminal will go here. Okay, now it works the other way around. When there's light, it goes to 0. When the input goes to 0, it goes to 1. It's disconnected. When there's no light, the output is connected. Okay. So basically I do it by reversing these connections, and I hopefully have something. Okay, I'll activate the circuit again, and hopefully I have something that activates when there's no light here. Probably I have to calibrate it again. Okay. I will try to make it a bit more sensible. That's it. Okay. So now it detects some object that interrupts light. Okay. So it's the same system for an alarm, like detects something passing by or whatever, or it can be also as well as we can activate a buzzer or an LED, we can activate anything. For example, we can use a relay at the output. A relay is a switch, a high power switch, but controlled by the signal here. So basically the symbol is something like this. I don't remember very well, okay, but this is a switch controlled magnetically. So we when it is connected, it will close that switch and we can use it to activate anything, maybe one light or some power device. Okay, one light, a machine, something that runs a high voltage, okay, at 240 volts or whatever. Okay, so it can serve as a detector. Then when it's at night, there's no light, it will activate light at the outside of the house, for example. Okay, now we have used a photodiode here. We have built our sensor. We have used a device for our sensor. We have used, as we did before, the potentiometer, but there are many types of sensors that are already built. This, for example, is a proximity sensor. Okay, it's an infrared proximity sensor that already has the electronics, the calibration potentiometer. So we will normally use a sensor already made. This one detects light, but the light reflected, so it detects when the sensor is in proximity with something. It's useful to build small robots, for example, line followers, or to detect some kind of moving parts when they cross across the sensor. The good thing is that because it uses infrared light, it does not depend on the ambient light actually. Okay, it generates its own light. So we are going to substitute then our sensor. We'll remove all this. We will switch our system off. And these sensors already have the terminal. We have to give energy to the sensor, so we have to use these VCC and ground terminals. So I'll use this cable. I will use this for ground, the white for VCC, and it has both a digital and an analog output. Okay, the digital output will be just high or low, 1 or 0, depending if it detects something or not. Because we are interfacing to a digital circuit, it's the one we need. But it also has an analog output. If we want to detect how much light is receiving, it could be good for other applications. Okay, so now we connect this to ground, connect this to VCC. Okay, now we are giving power to the device, and this is the signal that comes from the device. It's a digital signal already. So I connect it to the other input of my gate, and now when I approximate the sensor to a surface, to a reflecting surface, it will detect the proximity, right? Now I connect my circuit again, and you see that, okay? You know it's active low. It means it's in proximity with something. The output is 0, so the output of our gate is high, and we detect actually in this configuration when it goes out of the proximity. Okay, again we can move parts around to do the opposite thing. So but it's the same idea. Basically we obtain our input signal for a different kind of sensor. It's also a light sensor. We can use whatever we want. We have temperature sensors and many other things. For example, this is a volumetric sensor, like the one that you have in the alarm detectors in your house. This is also an infrared sensor somehow, but it detects when the infrared light that comes from objects, especially from living things, and it does detect not if there's light or not, but the changes on those in the intensity in the infrared light. So when objects move around, the intensity changes, and then the sensor activates its output. That's how these things detect moving things. So we can use that sensor as well. It also has the one on the right is the ground terminal. The one on the other side is the power supply, and the gray cable I will connect to the signal from the sensor. Okay. In this proximity sensor, in this volumetric sensor, we have two potentiometers here that we can adjust. We adjust the sensitivity, and we can also adjust how long it will detect movement. It will activate the output for some time when it detects the movement. Okay. So these sensors are very, very sensible. So I will connect it to the power supply. This is a digital output. I will try to put it here. Then I'll connect to the other input. Great. Okay, now it's supposed that, you see, when things move around the sensor, it should detect the movement. After every detection, it stops for some time, and then it starts detecting again. Okay. You can see my hand, but I'm just moving my hand around the sensor. So as soon as I make any slight movement, it will detect the movement. Actually, it's very sensible, so even if I'm at a few meters from the sensor, it will detect. I've stopped moving right now, but as soon as I move a little bit, okay, you can see me, but I'm moving at about half a meter from the sensor. But again, it's the same idea. Once you have your digital system designed, instead of building your sensor, basically you can use any external sensor that you like. Okay, some sensor, and you connect it to the input of your circuit. And because we have a digital interface, we don't have to think about the details. Of course, this NAND gate inside has transistor doing the job. We don't have the problem of amplifying the signal. This is strong enough to drive an LED or to drive a buzzer as we have. Okay. So that's it.